Using ratios to find segment lengths. And this is actually a type of problem that you see a lot on any kind of standardized test. So in the diagram, FG to GH is 1 to 3. And FH, the whole thing, is 12. So we need to go back and find FG and GH. So we know that FG is 1 and GH is 3. But if we add 1 plus 3, that's not going to give you 12. So we need to multiply that by the same number. We don't know what number yet. We're going to figure that out. So I'm going to put an x there because we don't know what number we're going to increase that by, and then 3x. And then you could just set up an equation, 1x plus 3x equals 12. Combine like terms, divide out the coefficient, and x is equal to 3. That's the scale factor. But then to find the actual length, you need to take that 3 and plug it back in. And then plug it in here as well. 3 times 3 gives me 9. So, and I can actually check because 9 plus 3 really does equal the whole thing of 12. So I know that FG, that small piece right there, is equal to 3, and I know that GH is equal to 9. Another way you can do it in your head is you know that there's 4 parts total, because 1 plus 3 is 4, and I know that GH is going to be 3 times as big as that little piece FG. So this is going to be 3 times as big as FG. So I'm just going to take the whole length, cut it up into 4 equal parts, and that's 3. So I know that FG equals 3, but then this would also have to equal 3, this would also have to equal 3, and this would have to also equal 3. Add them all together, that's going to give me 9. Another problem might look like this. So we have to go back and sketch a triangle, which I already did, and find the length and the width of the rectangle. So the length I normally think of as the longer side or on the bottom. Doesn't really matter, and the width we'll just say is the right and the left. So it says the perimeter of a rectangle is 132 meters. That means the distance around. So if I start there in the top left and go all the way around, I know the perimeter is going to equal 132 meters. The ratio of the length to the width is 8 to 3. So I'll just write 8 down here and 3 over here. And then the length is also on the top, so I'm going to put an 8 there and then a 3 across. So when I add up all those side lengths, I know that does not equal 132. So I know it can't be the numbers 8 and 3. We have to make them bigger numbers, but still in the same ratio. So what I'm going to do is just add an x on the end. I'm going to make all of them bigger by the same scale factor, it's technically called, and just go ahead and add an x. So that's going to give me 22x. Divide out the 22 on both sides, and then it's going to give me a value for x, which is 6. You're not done yet, though. You need to go and plug that back in. So 8 times 3 is 24. And 3, oh, no, I meant to use 6. So 8 times 6 is going to give me 48. And then 6 times 3 is going to give me 18. So that would mean this is also 48 up here, and this is 18 over here. And you can actually check 48 plus 48 plus 18 plus 18, it better add up to give you 132. So instead of the measures being 8 and 3, it's going to give you 48 for the length and 18 for the width. And if the ratio is 8 to 3, I'll just write that down here in blue. If you put, I'll choose gray. If you put 48 over 18 in a ratio, and let's just say divide by 2, 24 over 9, and then take out a 3. Notice how it simplifies to the same exact ratio as in the beginning. It's the same ratio, just bigger numbers. It's still the same relationship though. We just kind of made it work for the perimeter of 132 meters.